Please open in your learning workbook to page 158 as we do another example involving variation. The loudness of sound measured in decibels, dB, varies inversely as the square of the distance between the listener and the source of the sound. If the loudness of sound is 17.92 decibels at a distance of 10 feet from a stereo speaker, what is the decibel level 20 feet from the speaker? Okay, just like the last problem, the first thing we need to do here is we need to identify what are the quantities of this problem that can be measured with numbers, and what letters should we use to represent them. So the first thing that we're going to say is the loudness of sound measured in decibels. And we're going to call this L. L for loudness. And then the next quantity that we have in the problem that we identify is the distance between the listener and the source of the sound. And we're going to call that D. Okay, so now we're ready to write our variation equation going through the 6 steps. First step, identify what's doing the varying. It says the loudness varies. Loudness is L, so we start with the equation L equals. Step 2, create a fraction with a K in the numerator. Step 3, look for the ly word. Well, the ly word in this problem is inversely. Inversely means the stuff is going to go in the denominator, and the stuff is the square of d. So we put d to the second power, or d squared, in the denominator. Okay, this is our variation equation. Now we're going to plug in the information given to us as we move on to step 5. If the loudness of sound is 17.92 decibels, that's a value for L. So let's put that in our equation. 17.92 equals K over. Continuing to read, at a distance of 10 feet, that's telling me that D equals 10. So replace the D with 10. So that gives me the equation 17.92 equals K over 10 squared. This means that 17.92 is equal to K over 100. I would like to get K by itself. What's near the K? A 100. What is it doing? Dividing. To get K alone, we need to do the opposite. What's the opposite of divide? Multiply. So times 100 on both sides of the equation, and we get the new statement, 1,792 equals K. We can now put that in our equation to create a variation equation that tells us the relationship between distance and loudness. L equals 1,792 over D squared. Now, if someone gives us a distance, we can find the loudness. And if someone gives us the loudness, we can determine what the distance must be. Okay, this moves us on to the last sentence. What is the decibel level 20 feet from the speaker? Well, 20 feet is a distance. So we're going to take this equation and we're going to replace the distance D with 20. We get L equals 1792 over 20 squared. 1792 over 400. So L is equal to 1792 divided by 400, 4.48. And because L is measuring loudness, we write that it's 4.48 decibels. Okay, notice that the loudness of sound is 17.92 decibels at a distance of 10 feet from the speaker, but when the distance from the speaker is increased to 20 feet, the decibel level decreases to 4.48 decibels. This is consistent with an inverse relationship. For k greater than 0, as one variable is increased, the other is decreased. It also seems reasonable that the further one moves away from the source of a sound, the softer the sound becomes. We have confidence that our answer is correct.